Seawater is a mixture of many things. It is a mixture of metal salts like chlorides and sulfates of sodium, potassium, calcium and magnesium, and gases like oxygen, carbon dioxide and nitrogen. It's already a solution of so many substances. What else can we dissolve in it? Let's try. Take a bottle of seawater. Now pour some juice in it. The juice will mix with the water. Then try this with different liquids like milk, nail polish remover, liquid soap. It seems as if it can dissolve almost everything. But now try dissolving oil in it. We will see that unlike the other liquids, oil will not mix with the water. It just forms a layer above the water. This is often seen when an oil spill occurs at the sea. It happens when the oil leaks from the ships carrying oil from the oil mines. So why does oil not dissolve in water? Why do some substances dissolve to form a solution and some don't? Let's find out in this video. But before we proceed, let's first have a look at some terms related to the components of a solution. We saw in the previous video that a solution is a homogeneous mixture of two or more components. We usually divide its components into two groups. The component in the largest quantity is called as the solvent, and all the rest are called solutes. So we can say that the solutes dissolve in the solvent to form a solution. For example, in seawater, water is the solvent and all the metal salts and gases dissolved in it are solutes. Remember, a solution will always have only one solvent but can have more than one solute dissolved in it. But in this one and the upcoming videos, we will only focus on binary solutions with a liquid solvent. That is, the solutions with only one solute dissolved in a liquid solvent. So now, let's get back to our question. Let's say we want to form a solution of these two substances. This is our solvent and this is our solute. Now we will have a look at their molecules to understand whether they will form a solution or not. We know that the molecules of a substance attract each other. So here, there will be attractive forces acting between the solvent molecules and similarly between the solute molecules. We denote the interaction between the solute molecules as solute-solute interactions and similarly for the solvent as solvent-solvent interactions. Now, let's try to mix the two substances. We can see that here the solvent molecules and the solute molecules will get a chance to interact with each other. So in the mixture, there will be three kinds of interactions: solvent-solvent, solute-solute, and solvent-solute. Now the formation of the solution depends on the nature of these three kinds of interactions. It has been observed that a solution will form only when these three kinds of interactions are of the similar type and strength. What do we mean by it? We will understand this through some examples in the next lesson. We have seen earlier that there exist different types of intermolecular interactions depending on the nature of the molecules of a substance. To understand them better, you could watch our videos based on intermolecular interactions. To stay updated and to keep learning such interesting things, go ahead and subscribe to our channel.